Okay, we are most often concerned with the value of delta S rather than the value of entropy of a given state. We can calculate delta S by S final minus S initial. In this example here, we're going from a system where there's one microstate to a system where there's 1, 2, 3, 4, 5, 6 different microstates. So we can calculate delta S using Boltzmann. Boltzmann tells us that the entropy of a state is equal to K, the Boltzmann constant, times ln of W. We can apply that to this situation. Okay, so we have the final state and the initial state. WF corresponds to the number of microstates associated with the final situation. WI is the number of microstates associated with the initial situation. If we substitute in our values for the Boltzmann constant and the microstates in the final versus the initial state, we can get a value for delta S. And it's no surprise here that delta S is going to be greater than 0 because we go from a more ordered state to a less ordered state. Factors that influence the magnitude of entropy. Phase and temperature are the primary factors we're going to be concerned with. A solid state has the lowest overall entropy. The particles are held in place. There's relatively few distributions or microstates associated with a solid. There's more freedom of movement in a liquid. The particles can slide over each other, and therefore there is a higher corresponding disorder. Gases are much, much higher in their disorder than either liquids or solids. If we look at the effect of temperature, as the average kinetic energy of particles increase, they have greater freedom to move around. There's going to be a corresponding increase in entropy. We see this very easily in the cartoon here, where we see as temperature increases, there's going to be an increase in temperature. And further, there's a huge jump in the magnitude of entropy at each phase change. There's a big jump between solid and liquid, and a much larger jump between liquid and gas. Weaker influences on the value of entropy are the number and types of particles that make up the substance and the variation of the particles, whether or not you have pure substances or if you have a mixture.